Hi. I just want to explain how this Moly mold activity works, and that is for the butane combustion conservation of mass bit. So first off, students will get a container with 5 carbons, 4 oxygens, 12 hydrogens, and 18 little bonds. The first thing I'm going to ask them to do is to make the molecules in that equation. So to make butane, we're going to do see, to make butane. First one that they need to make. These little lobbies. Cool. That's my butane. Hydrogen's in there. I'll write this all up as instructions as well, but I figured a video will help visualize what I'm trying to do. All right. So there's my butane. The other thing I'm going to ask them to make is make oxygen. Red representing oxygen, black representing the carbon, white representing the hydrogen. I also ask them to make carbon dioxide. Looks like I'm short a hydrogen on this box. That's not good. I did not count properly. Hydrogen summary. Oh, I didn't need 4, I needed 5. I did not math properly. That's okay. Extra 5 one in there. All right. So sorry. Should say 5 carbon, 5 oxygen, 12 hydrogens, and 18 bonds. So that's what that looks like. So we have our oxygen, our butane, our water, and our carbon dioxide. The first thing that I would have students do is just look at it as an unbalanced equation and just trying to think about, what's happening in this reaction. Second thing I would then ask, so I would be talking about how this butane, when it breaks apart with the oxygen, it's going to form 2 things. The carbons are going to form the carbon dioxide with the oxygen, and then the hydrogens are going to form water with the oxygen. Then I would ask them, okay, so we need to make sure we have conservation of mass. So basically, how many oxygens would I need in order to make enough carbon dioxide? And so that answer will be 1, 2, 3, 4. So they need 4 molecules or 8 atoms of oxygen. So I said, cool, that's great. I want you guys to bring up your carbon dioxide and your water to me. Hold on to your 1 oxygen, and I will give you 3 more oxygens so you can break that molecule apart and you can make carbon dioxide. Just keep in mind, so I have a whole box full of oxygens here, and I'm going to put these discarded stuff back in here so that way we can use it later. Something to keep in mind is that the carbon dioxide obviously isn't straight chained. I opted out to not do the double bonds because I figured that would just be too confusing for the juniors. If it was a senior class, probably. Only for like level 2 chemistry. The other thing they'll need is an extra little knob bond. So grab that. So when they come up to you, they should be returning their water and their carbon dioxide. You give them 3 more oxygens and an extra knob. Then they're going to break this apart, take out all the hydrogens. Actually, you probably don't need to give them another knob. They can give them the hydrogens. Works. take all those hydrogens off, then they take these guys apart, and then they just start adding their carbon dioxides. So the reason why I want them to break and make the molecule is so that way they can actually visualize what is happening, and just tell them to steal one of the bonds off of the hydrogens. So they should see that they get 4 carbon dioxides from there. Cool. This is also a good chance to start giving them the opportunity to think about coefficients and subscripts. So coefficient-wise, there are 4. Subscripts, there's only 1 for the hydrogen. So 1 times 4 is 4 carbons. And then each carbon dioxide has 2 oxygens, which is a subscript. But 2 times 4 is 8. Just getting them to start thinking about that number. So that's my carbon dioxide sorted. Now I have all these hydrogens here. And they need to figure out how many oxygens do they need in order to make water. So they should realize they have 2 in each water molecule from what they had earlier. So they have 2, 4, 6, 8, 10. So 10 divided by 2 is 5. So they need 5 oxygen atoms. Unfortunately, we can't break apart these oxygen molecules to be individual, so I have to give them 3. So I'm going to tell them that I have to give you 3. They are given 3, and then they start making their water molecules. Like so. There we go. So here are my 5 water molecules, but the problem, and again, you can do the same sort of refresher on coefficients and subscripts and getting them to count, but the reason that we want to do it incorrectly is so that they realize it's a leftover oxygen, and we can't have a leftover oxygen like this. So at this point, then, I would say to the class, okay, I want you to buddy up with another group, so that way you guys can take your oxygens, put them back together, and then give it back to me. So that way they don't actually need all those oxygens that they have been given. So that's how I want them to think about that. And then that is then kind of giving them the idea that we need to double this equation. So that way there's a total number that then works. So what the students can then do is they can look at that total equation, they can go through and they can count how many carbons are on this side and how many waters are on the product side. And then what I would ask them to do is, all right, I want you to go backtrack and I want you to make the original products now, just to make sure that we can count the atoms from the product end. So kids are going to need to take things apart again, which is good. That way it hopefully reinforces it. It also means that it helps you get it reset for the next time they do this, for the next class. So breaking everybody apart again. And this they're going to be working obviously in their bigger groups. So potentially pairs to start off with, or groups of 3, and then when they combine it together, then they can when they combine together, then they can reset their things. So that's that. Let's put the hydrogens back in. So they should have 2 butane molecules if they're in their doubles now. So that's my, nope, not done yet. Got a carbon there. Oh dear. Go back and make their 2 butanes and all their waters, sorry, all their oxygens, and they can count again. So here we go. That's a butane. So if they're in a group of, or sorry, if two groups have joined together, then they'll have two butane molecules to count, and then they'll have their oxygens to put back together as well, which is useful for you because then you can easily reset everybody. But we got a couple of extra leftovers, so you might need to get some extra little knobs. So I have another bowl of just knobs. All right, and then they can go through, like I said, just count all these, and then when it comes to packing up and cleaning up, then go, okay, what I want you guys to do is hold on to one of your, so break up into the original groups or the original pairs. Each group takes one butane, each group takes one one oxygen. All the other oxygens come back to Miss, and when you return those to Miss, she will give you back your water and your carbon dioxide, and then you can dismantle all these and put them back into your cup, so that way other people can use them. So that's the idea behind that. So I'm gonna get another cup of just these knobs, just in case you need more of those, and I need to put an extra carbon in everybody now. Sorry, hydrogen. No, oxygen. Brain's not working. All right, I'll type all this up too, but that's how I would do it.